Damn. What a nice video. Maybe I should also release some beginner guides. If you want to create a game rendering in 3-dimensional space, sooner or later you will face the necessity to have an animated character that, most probably, is animated with skeletal animation technology. In this video, I will teach you how to create them and a couple other things. Watch closely, and by the end of it you will be able to answer the question that haunts generations of Godot users. Why the fuck doesn't my animated scene work? And to truly understand what happens, it will be beneficial to truly understand what skeletal animation even is and why things do work. For this reason, our journey actually starts not in Godot, but in some 3D software. As a poor as indie, I will use Blender, but this theoretical knowledge is universal and independent from the software you use. A character's model is probably large, thin and smooth at the same time, what means it's a very complex mesh with a lot of vertices. It is important to understand that if we want to animate it, we need a nice way to actually deform it and re-render anew. So if we have our character in two different poses in two different frames of animation, from one math parts perspective these are two different geometry figures, and from another math parts perspective these are two somewhat equal figures in which we can strictly put all vertices, edges and polygons in a parity map, so like they have the same amount of walls and holes, they just have some slight differences in vertices coordinates. However, slight to note, we still need to re-render this shit, and quotes slight differences in vertex coordinates quickly become a huge problem if there are several thousands of them vertices. There are some dark magics floating in this pool, but for now let's just declare that working with direct vertex movements is a nightmare. Firstly, human beings generally are not so good at animating something 2D in an old school drawings way, and another full dimension is a complete deal breaker. And secondly, how do you imagine a data format for that animation thing? You have a track entry per vertex and you store a 3-dimensional vector with like at least 4 digits per coordinate and probably more. Those animation files will be able to win a professional sumo wrestling tournament. So, humanity invented some hacks. In its core, the idea is old as time and is used everywhere in programming sphere. We will make an abstraction. Imagine we just gather all these little fuckers and tell them, hear me out guys, here's a magical stick. It has a start and an end. We will move this stick from time to time. Your task is to copy its delta transformations and do the same. In other words, we abstract our picture and work with one 3D transform instead of all those vertices. We then do another step in this direction. We break our mesh on sub-collections of vertices that look at their sticks, and then we also declare that our sticks are actually a parent-child hierarchy. So when we move one magic stick, all its children accept the transformation as well, and their children, and so on and so on. And at the same time, all vertices listen to our stick's movements and obey them as well. And now, our mid-sax animators have an achievable task of just animating those sticks, and simultaneously we get a huge win in data storage department, because all we need to store is an entry per vertex about what stick does it obey, and then for animation we just have an entry per stick, which is like at least 2 to 3 magnitudes win. Now, the thing I just told you is an extremely simplified explanation of what actually happens. For general education, that's okay, but if you want to go a little bit deeper, in reality a vertex doesn't listen to only one bone. A vertex can listen to any number of bones from mass perspective, but most of the engines and data file types support 4 influences per vertex. And influence is a float parameter from 0 to 1, which tells how strong is the impact of a bone's transformation for this exact vertex. This approach with several influences is the answer to the question, why doesn't our mesh break to pieces if we input a big delta transformation? It also answers to the tricky questions about how to animate knees and elbows without depression, how to distinguish between some hard object like a metal pauldron and a firm object like some beard, which is also located dangerously close to the chest, but must obey some head movements, etc. This area of knowledge is called character rigging, and it is out of the scope of this tutorial. What I want you to understand as a fresh Godot user is that we have 4 different logic logical data collection entities on our hands. First is our actual mesh data, a list of vertices, edges, polygons, coordinates, yada yada. Godot calls this thing array mesh. The second entity is a collection of our magic sticks that Godot calls skeleton and Blender calls armature. Third entity is really important. It is the data that marries mesh to its skeleton, and most commonly this data piece is called in the industry as rig, and in Godot it is stored in two places. We can access vertex bone influences directly from a mesh resource, but there is also a small helping resource called skin that is used as a better abstraction layer over a literal array of arrays of 4 floats and is used in dynamical binding. And the fourth data piece is our actual animation data that stores the information about individual bones being transformed in space and time. In this context, when we talk about animation, there is an invisible contract being in place that this animation actually describes the bones of this skeleton. Otherwise, there is no much sense in discussing it. So, let's look at this picture and imagine things being broken. For starts, well, if we don't have a mesh, then we have nothing to render. We can set up a purely logical skeleton running in space, but it won't move any vertices and no rendering will happen down the execution flow. If you are missing an imported animation data, then you have a skeleton that is properly rigged to some mesh and is able to move it, but no movement will happen unless you manually deform the skeleton in the runtime or create some animation inside of Godot. If you are missing skeleton while having a rig for it, then something probably went wrong. It's a rare situation to end up, but until you find it, your mesh remains static. If you are missing the rig data, then your mesh doesn't know about skeleton's existence and is practically a static object like a rock or a building asset. It will be rendered, but won't ever deform. And the thought that is the most important to demystify this process in your head and escape cargo culting some character importing videos is that these components, while being tied in a working configuration, can be worked on independently and mixed and matched if you have awareness of your goals and actions. Like, we can have a mesh rig skeleton structure ready and just give it more animations if we obey the contract that this new animation is actually for this skeleton. Or we can have skeleton plus animations, but decide that we want to swap our character to a different visual mesh. And if done right, and we probably update the rig, it will be able to use old skeleton and all old animations. Now let's slowly move to Godot. And to move from a 3D software to Godot, you need to export your character as a 3D object. There are different formats, but if you have experience working with other engines or with 3D, you are probably set on using FBX. And I strongly recommend to not do that and use GLB instead. There is no strict breaking points. If you understand fully what happens and all your other pipeline depends on FBX, you can make it work. But if you are new, then by using FBX from the start, you sentence yourself to a dev by 1000 bullshit problems cuts, what may lead to a quicker burnout. Godot just doesn't stack with FBX very well, but I won't spend more video time budget on that, so exporting as GLB and throwing it into projects folder. And now, ladies and gentlemen, you just take your fresh GLB file and drag and drop it into some 3D scene. Voila! Gotcha. You thought you can escape the claws of my explanation, didn't you? Not so fast, you speedsters. In reality, the thing you threw into projects folder and grab with your cursor in this panel is not the thing that appears in the 3D scene when you let go of your mouse button. This drag and drop masks a lot of internal stuff that happens on the background, which makes you walk faster but can obscure some essential understandings, especially when you are a beginner. The GLB file that lies in this folder is just a data container that describes an object in 3-dimensional space. It is not bound to Godot by any means. It is a way to store and transport data about objects. What was spawned here in the 3D scene is, well, also a scene, because almost everything in Godot is a scene or a node, especially in the beginning, and you just can't describe a random 3D data here and append it to a scene tree. Like, scene tree is built from scenes, not from random files. So somewhere during this drag and drop, an invisible daemon appears and helps you to convert this 3D data file into a set of native to Godot abstractions that you can use further in your development inside the engine. Well, this daemon actually appeared much earlier than drag and drop. He did his invisible work here. Welcome to the new chapter, my friends. Understanding the import process. There are only 4 file types that directly describe Godot's in-engine entities: scn, tscn, res, and tres. In other words, scenes and resources. Every single file of any other type must undergo a process called import before Godot will be able to work with them. And here in this file hierarchy there is an invisible folder called .godot/imported. In this invisible folder, Godot keeps its internal interpretations of these external files. When a new file appears, Godot creates an approach to import it and associates an internal resource with this new external file. So what truly happens during this drag and drop is Godot, being a smartass who understands you need this 3D object in your scene tree, takes the internal resource that is associated with this 3D file and spawns its content to the scene instead. Why do I sentence you to having this process understanding from the very start? Well, it can have drastic effects on our character creation pipelines. Let's inspect our options. There are 2 big interface pieces that are tied to it. First is this panel tab that is called import. It will be empty unless you have a selected file down here. And if you have one selected, then everything this tab contains is about the import settings for this exact file or files. It supports multiple selections and this is the upside of the import tab. Second part is the window that appears if you double-click the file in the file system. To start, it literally contains the whole import tab here in the scene. The only settings we are missing here is the topmost menu that allows us to skip importing this thing as a 3D object and just take all animations from it, but more on that later. However, there are extras. First very practical thing is that it shows you how the scene that will be imported looks like. This is one of the fastest way to check if you did something wrong. For example, if you create your character in Blender and then somehow export only the literal mesh, then Godot, being a smartass, won't generate any skeleton or animation player. It will just import your mesh as a dead raw cassette. Just a root 3D node with a mesh instance child with your model being packed into its array mesh resource. Or if you have your model rigged properly but pressed some wrong buttons on this fucking NLA tracks tool, you then double click the GLB file, boom, it has model and skeleton, but it won't have an animation player, or it will but it won't have animations listed, I don't remember. Looking at our particular example, we can see that the created scene will internally consist of a node 3D, which consists of another 2 node 3Ds. One of those will be named armature, it will have a skeleton 3D child, on it we will have a meshed instance 3D node, which will have array mesh resource named Shogun Dance Body. We will also have an animation player here with one built-in animation that is called Dance Moves. Firstly, all of these elements are clickable. You can click at mesh instance to look at non-deformed mesh state, you can click on skeleton to make bones visualized, and of course you can play the animation to make sure everything works fine. Secondly, every single one of these nodes have a right panel that allows additional customization. For example, we can select this unneeded node 3D and just click skip import to exile it from the final scene result. The things you changed here will prompt you to re-import an asset, and if you do, it will change all the unpacked instances of that scene as well. Look, I import the scene with unneeded node, then I open it again, skip import on body 1, click re-import, and now when I unpack previously imported scene, I won't see the body 1 node here. We are also allowed even to add some custom scripts onto these nodes, so in some world where you watched a bunch of bullshit tutorials that advocate for importing a character as an unpacked scene, you can customize it to space and beyond by straight up injecting any functional you see fit. However, I personally would not do that. In my opinion, for characters specifically, it is much better to unpack the scene and repurpose its parts as you see fit later instead of injecting scripts here, despite the ability being present on the table. Anyways, this window is powerful as fuck. For your best interest, I encourage you to experiment by yourself, inspecting what options you have by clicking shit randomly. However, powerful but not omnipotent. We still can go deeper. The truth is, the machine spirit blessed us with an ability to hook to the import process and directly manipulate its output, recruiting might of the Holy Scriptures to our aid. I do remember that this video is a beginner guide, so we won't do any fancy stuff, don't be scared, but I have to at least show you the window from which you can observe the borders of achievable. Let's create a script somewhere here. For a default option to do nothing, it has to have 4 lines. This orange thing is called annotation. You might be familiar with it from other languages. It is something some sort of meta information that provides some context to a compiler while not being an actual operator, function or field, etc. In our case, we use annotation tool to tell the engine that this script is something that we expect to run outside of runtime. In other words, it is a helper script that we run in editor to manipulate things in our project during development. The next line tells us that the class will be described as an heir of the built-in class editor scene post import. Then we describe a function. Or, to be precise, we override a function. Generally in Godot, when function's name starts from an underscore, it means that this function is something internal and built-in, and that function is placed to be called in some predefined conditions that are already set up by the engine. In our case, the post-import function is provided to us by our ancestor class, and, well, it is called when the file is imported and turned into a scene, but before that scene is saved to the import folder. It provides us this newly formed scene as the function argument and expects us to return the scene after we did our additional work. So these 4 lines run the extended import functional, but don't actually change anything. As soon as we get our scene, we immediately return it as is. For now, let's just drop a line to the console to make sure the thing runs, then save script, then select it as a post-import script for our waifu. Again, this is a beginner video, so I won't fuck your brains hard. Let's just demonstrate that we can manipulate our scenes from here as well. For example, we can add here a simple node, set its name and forward the scene. And when we do, resave and reimport, we can unpack this scene and yep, our node is just chilling here together with all the stuff we brought from Blender. By no means I enforce you to actually use this tech. Just know that it exists somewhere out there as an option, because this is one of the windows into advanced Godot usage. For now, default settings are more than enough to satisfy our needs. And friends, if you just leave this video remembering nothing from it aside from what this drag and drop action hides, you are already miles better than a newbie, so don't feel pressure whatsoever. And we are moving to the next chapter. Earlier, we spent some time in Blender to learn theoretical concepts about our entities. Now, let's understand what actual Godot components implement those concepts and how they work together to render the dancing waifu onto your screen. Our actual geometry data, i.e. mesh, is this mesh instance 3D node. Mesh instance 3D is just a glorified node 3D, mostly it's just a container to store the data that wraps it and turns into a node. Our actual 3-dimensional waifu lives here, as a resource of type array mesh in the mesh instance 3D's export field. Upon inspecting it, we can see here the mentioned skin resource, and we also have a set export field pointing at our skeleton. So we have a mesh, it is rendered, it has its rig data, and we almost can't fuck that up. You either have that set right, or you don't have the data at all. To have a rig being present but corrupted is a super rare situation that probably started as a result of some botched post-import script. However, you probably see that we are bombarded with error pop-ups that tell us something track is not resolved. And indeed, if you just play the single animation that we have in the scene, it is being played, so we have some data here, but nothing happens. Our waifu is paralyzed and angry at us. So, I'm 100% certain that our model is probably rigged and is capable of moving, solely from the fact that this animation was played during the import preview phase. But let's check that fact via moving a bone and ascertain that our mesh is capable of being deformed. We can select our skeleton and see the actual hierarchy that it contains in the inspector panel. All those sticks are touchable, so feel free, let's grab a random bone and change its rotation or position. Yep, our mesh deforms. It means that our waifu was actually imported properly. It knows about skeleton existence and reacts to its movement adequately. And the only broken thing is our animation. Well, no steps skipping today. We have a badly configured animation player node here, and I want you to be able to fix it yourself by the end of the video. So let's first understand how does it even work. Let's temporarily teleport to a completely separate new scene and just discuss the animation player. And while we are here, let's also add another mesh instance 3D. This is how this node looks like when you create it manually. And it's just nothing, because our internal mesh resource is nothing. Sadly, Godot can generate waifus from non-existence yet, but we have several other templates here to choose from primitives, for example, cube. Now, animation player. This node is made to change values over time, and since most of the things in our world are actually values, this node is one of the most powerful nodes in all Godot. Floats are numerical values, so it can blend them smoothly. Vector 3s are made from 3 float numbers, so it can blend them smoothly. Transform 3ds are made from 4 vectors, so it can blend them smoothly, and so on and so on. It can even animate your 2D sprite-driven pixel art games, because guess what? 2D pixel art sprites are stored in a structure called sprite sheet, and each sprite has an integer value ID associated with it, and integer is a numerical value, so you can change those thingies via animation player as well. In fact, down here we have a whole subpanel called animation, and if you click it, something funny happens, and inspector panel starts to draw a small key icon near the values that can be changed via Godot's animation system. To make a moment more powerful, I will demonstrate it in my indie project instead of our demonstration room. Ready? Yeah, this thing can change more than it cannot. You pretty much can animation player your game into existence, however I would advise against it. So how does it work? Firstly, we need an animation, at least one. If our player doesn't have any animations, it won't be able to play them. Also, there is a newbie bit. Very often when you check out other tutorials, they will import a character into the scene and make it local, and then happily press these interface buttons around here set up in their nodes. And you will repeat every single step by the video, but when you will do it, you will get a castrated animation player with half of the buttons grayed out. This is a super duper default newbie error. It happens because the freshly created scene sort of doesn't exist yet, and some of its capabilities are inaccessible. So all you need to do to enable your grayed out buttons is to click here and save your scene with some actual name. So let's create an animation. Name doesn't matter, interface basics. Top row is the animation chosen to be played. To the right from it you can see and change animation's length and looping mode between 3 values: none, cyclical or bouncing. To the left you can see the current progress in which the playhead is located. Button Edit hides in animation management like working with keys or tracks. However, you will probably press it very rarely. Godot is not a proper 3D software piece, and trying to use it as one is a suicide. The animation button hides macro animation management such as creation, deletion, and this fancy window that won't show much for now, but will have a lot of sense down the line. Let's create a new track. Track can be empty, so we want to bind it to some available value in the node. For example, this cube's X coordinate. Right click, create key, right click, create key. Now we select this keyframe, set its timing to 0 and leave as is. And the second keyframe we will put to animation's end and give it the value of 2 meters by X axis. Behold the results of our tedious work. Now I want to clear 2 newbie misconceptions. Firstly, animation is just a data, and animation player can play whatever the fuck you want from it. Despite skeletal animations specifically usually contain only the information about bone movements, we are not bound to one object. I can freely create here another cube and create another track that will play something else, and it will work. Secondly, keyframes are called frames, but their only function is to be timed data entries in a glorified dictionary that is called animation. They have nothing to do with actual frame rate of your game. This animation has 2 keyframes, but if we have a nice enough hardware, we can get whatever amount of frames rendered from this animation, like 500 will do. It happens because of when game requests animation player to calculate the value of the track. If the track is of mixable value, it will be interpolated between 2 closest keyframes to the left and to the right. So despite our actual data has only 2 entries, I can still retrieve the value for my parameter at 0.12345 timing if I wish. It will be calculated properly. This is the reason behind things being so smooth when you drag the playhead here slowly. Animation Player is a huge-ass piece of API. You can check it for yourself, I believe in you. That's all secondary knowledge. The primary knowledge is what actually happens under the hood. Once in a while, be it a rendered frame, or a physics update tick, or a manual kick from the game's code, Animation Player updates. We can regulate its update mode here in this field. When animation player updates, it checks if it does in fact play anything. Our discussion makes sense only if it does so. It has a parameter that points to the current animation and the playhead progress inside that animation. Then, it literally reads every single track from top towards the bottom and interpolates a value for the current playhead progress, if it can, takes this value and shoves it into the corresponding parameter in the scene. And the way it finds the corresponding parameter in the scene is by looking at the track path. Track path is sort of a glorified string with some self-awareness. It is similar how the file system paths are presented in our operation systems. You can click the track and it will show you its full path and even will allow you to change it. And here we finally are coming to two opportunities to shoot our dick off that most of the newbies face at least once during their Godot adventure. Firstly, look what will happen if I hide one of our two mesh instances under some functionless nodes. It was created by our own hands right here in the scene, so when we reparent the node, Godot editor is actually smart enough to change the track path, and our animation didn't break. However, it doesn't always work that way. And secondly, look again at this track path. It starts from the top node of our scene hierarchy. A question, ladies and gentlemen. Is our scene a main scene in the game, and we guarantee that this node is the next thing after the tree root? Or maybe a magical demon signed a contract with us promising us that this node will be located closely to the root? None of the above. This scene can even be instantiated many times during the runtime, and inside every single one of its instances there will be a working animation player that plays the animation. The answer to this dilemma is that these track paths are local, and they are calculated relative to one node, and not necessarily to the top one in the hierarchy. Our track paths are calculated relative to this animation player's root node parameter. Now let's do something funny and set it to some random thing. To the animation player itself, for example. And now our animation tracks are being broken because animation player searches for node 3D child with node 3D child with mesh instance child, but such node structure is not present in the scene. Now I take this structure as a whole and reparent it to my animation player, and what will happen? 3, 2, 1. Our animation will be played on this cube, because this track path is legitimate now, but won't play on this cube because its track is still broken. Funny enough, now when the scene is fixed, I can actually reparent my shit and Godot will cover my ass by changing the paths as well. Look, this 2 dots symbol is a universal code for whatever node that is my immediate parent. Finally, a question for people who listen carefully. What is wrong with our waifu animation here? Yeah, we are breaking this contract here. Our animation exists, but it is not for this skeleton. Our animation search for a node named Shogun Raiden, which has a child named Armature, which has a child named Skeleton 3D, and inside that skeleton it searches for a bone named Hips. And since such a node doesn't exist, our animation tells us that our track is broken and skips it, and then does the same with every other track because all of them are trying to find the Shogun Raiden node and fail. Now, I will soon show you the method to fix this with one button, but I want to stress another time that we here have a mission. I don't want you to leave this video with knowledge of this solution existence. I don't want you karagakulting any buttons. Your problem is not magical button not being pressed. Your problem is not your character not being imported properly. And your problem is not that you decided to rearrange nodes in your scene tree and broke shit. Your problem is that you have here a misconfigured animation player node that searches for its track values in the wrong place and can't update your game properly. And any solution that will solve this misconfiguration for you will work. Watch my hands. I can literally click this track, manually delete non-existent nodes from here, and voila, I got myself one properly working track for Hip's bone position, and it will be animated. Obviously, manually editing all these tracks is not an option really, but at least that will work. Alternatively, you can write a smartass tool script that will iterate over your scene and fix all the track paths with code. Alternatively, I can just create here two nodes that are named Shogun Raiden and Armature and recreate the configuration my player searches for. Also fix our hips back. Lo and behold, Our tracks do resolve. However, I don't want to have these nodes here, why do I need them, right? There is a solution that is ultimately better than all previous ones, and it is hidden back in the advanced import settings. Sorry sweetheart, we consider you broken beyond repair. It is easier to get a new one that works. Back here we can select the skeleton, then here in the retargeting menu we can create a new bone map for the skeleton. This is a very broad topic that is beyond this tutorial's scope. We are interested in only one setting here. Make unique. As a bonus point, you get to rename your skeleton. And now, upon reimporting and reinstantiating, we see that nothing was actually changed aside from one little symbol of % here on our skeleton. This % is a naming convention. We can name a node and include a % symbol as a first character, and if we do, this node sort of becomes a singleton for the scene. I can't have here another node that is named % Skeletal. It can't happen. And because our skeleton node's name is now a singleton, we can use just its name to access it by name instead of a track path. And Godot understands it and actually imports our set with tracks for this skeleton just containing its name, and that's it. Look, Skeletal hips. And because this track path now contains a unique node that we can get from any part of the scene, we can move it however we would like. It won't hide from the piercing gaze of our animator. It has a GPS tracker on its ass and we can get it from Mexico. Well, we successfully learned a couple of things, imported our character, demystified our actions, and from here you pretty much on your own. So let's reiterate the most important lesson that I hope you will take out of this video: how to debug your bullshit. We start from the border between some 3D software and Godot. Check your 3D file. Does it have a literal mesh to render, a skeleton and animations for the skeleton? Don't be lazy and check all animations that you have. I know you people will go through the process of downloading a bunch of mixem animations and gluing them in Blender. Sometimes you make mistakes there and you get like 3 animations for the skeleton that is called something something layer 1 mixem rig blah blah, and then you have one animation that for some reason has layer 1 mixamarik 1 blah blah, and those tracks will miss the skeleton. If you don't have everything of this checked, return to the 3D software of choice and export your shit properly. Then go into Godot and unpack your scene. First check your mesh. It must have a skin resource present and a link to your skeleton set. Keep in mind that these two are just a resource and just a link. You can freely delete this mesh from here and store it in some other place. You will just need to bring its skin with it and give this mesh the link to your skeleton during the node initialization on ready. Then check that your mesh obeys the skeleton transformations by moving a bone. If it doesn't, search for mistakes in import, missing resources, binds, etc. Then check your animations. Do they play properly and make your skeleton move? If not, check animation player's root node and make sure your track paths are correct. And the final tip, in the real development process you rarely need to import the whole character. Most of the time you have a character scene set on your hands and you need to just add some new animations to it. And to do it, you can just use your animation player's interface. Look, here in Macro Animation Management we have a window that lists all animations and animation libraries known to this animation player. You can create a library here and pull animations one by one. You can also straight up load here a ready library that is a resource somewhere in your file system. And there is a feature that stacks with this library loading very well. Library is just a resource that contains several animations, and when you import your animated character, you can actually use the import tab and skip importing all the stuff this asset holds. You can just select import as animation library, then rename your skeleton, set the post-import script if you wish, and when you hit the reimport button, this thing will turn into an animation library resource that you will be able to lap from here. So like, you have 20 animations here, you want to add 5 more, just export those 5 animations from 3D software on one armature, import it to Godot as animation library, and pull it up from your animation player. Whew. What a run, huh? I hope my beginner guide was of help to you, and thanks for watching. The next episode of our Advanced Newbism series will be a beginner guide to the scene tree. We will mostly discuss this left panel and what it can do, and a couple other things.